Is a magnetic shield the first step for a true Mars colony? Does stuff near the black hole spin faster than stuff farther away? What is the most "I can't believe this is my job" moment that I've had? And in Q&A Plus, do I follow Nordspace and their launch facilities in Newfoundland? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down, gather them up, and I will answer them here. All right, let's get into the questions. Perry, if we could put a 1 Tesla magnetic dipole at Mars' L1 Lagrange point to encompass Mars and a magnetotail, wouldn't that be a good precursor to eventual colonization? Yeah, if you could put a 1 Tesla magnetosphere around Mars, then there would be all kinds of good things that would happen for Mars habitability. So the big thing is that Mars is bone dry today, that the amount of water present on Mars is very low in the atmosphere. We can see that there are polar ice caps, and those ice caps contain water ice with carbon dioxide on top of it. And astronomers, so missions have gone to Mars and have dug into the regolith and determined there is, in fact, water mixed in with the regolith on Mars. So there's no water. It's that there's no water that's kind of available in the atmosphere, and that the atmosphere is very thin. And the other issue is that the solar radiation, the solar wind, is constantly buffeting Mars. So anytime any water vapor, any hydrogen molecules get out into the atmosphere, the solar wind will carry them away off into deep space. And so you need to prevent the solar wind from reaching the surface of Mars. And on Earth, we do that with a magnetosphere. Thanks to this dynamo at the center of the Earth, we have this giant magnetic field that surrounds our planet. And so when the solar wind is trying to blow away the particles from our atmosphere, the magnetic field redirects the solar wind and stops that process from happening. There's been some really interesting papers talking about this, that if you just blocked the solar wind, then Mars would change for the better. And it wouldn't take a long time. So if you could somehow just block the solar wind from reaching Mars, then all of this constant volcanic gases that are just escaping from Mars all the time, there's carbon dioxide, probably methane, other gases, they would just thicken the atmosphere and thicken it and thicken it and thicken it. And, eventually, it would get to the point where liquid water could actually exist on the surface of Mars. Now, you wouldn't be able to breathe the atmosphere, it'd be carbon dioxide, but it would be thick enough that the water would melt, that you would actually start to get standing water on the surface of Mars. And that's just by blocking the solar wind. But what you're proposing is a mega engineering project beyond the likes of which we are able to do. We are not able to generate a magnetosphere at a planetary wide scale. It's just like you need to turn the center of Mars into liquid, a dynamo in what the Earth has. But there is an idea that I like that's sort of on that same pathway, which is that instead of trying to surround all of Mars in a artificial magnetosphere, you just need to block the solar wind from getting to Mars. And so you could put an artificial magnetosphere at the Mars-Sun L1 Lagrange point, so the point in between the Sun and Mars. And it can be much smaller. It doesn't have to be gigantic. It just has to be big enough to essentially cast a shadow, a solar wind shadow on Mars. And now Mars would be protected from the solar wind. And then these volcanic gases would start to replenish the atmosphere on Mars. Now, that still wouldn't protect you from the cosmic rays. So, and they are the more dangerous ones. So we talk about these radiation hazards that you get when you're out in space. Like when you are away from the Earth's magnetosphere, you are going to be getting about 200 times as much radiation on your body as you do when you're down on the Earth. And so being outside on Mars is just very, very bad for radiation. You would be blocking the solar radiation or the solar wind particles, but they're minor. They're not that bad. It's the cosmic rays that are coming from all directions. These are accelerated by supernova and quasars and gamma ray bursts and who knows, pulsars, and that they are still going to strike the surface of Mars. And so you're still going to need radiation protection. It will get better when the atmosphere on Mars thickens, but it will never be safe. It will always be a place that you're going to spend. Like you think about getting a sunburn is bad, right? You just put on some sunblock and now you're okay. Well, there is no sunblock for cosmic rays. So you will be sort of counting every second that you have to spend out under the sky on Mars. Gweeble. Regarding the accretion disks, do stuff near the black hole spin faster than stuff that are more distant, or dark matter influences it too, so everything spins or at the same speed? So the question that you're asking is this idea of the speed that stars move inside a galaxy. And this is sort of one of the indications that whatever is the mass of the galaxy, we can only perceive a fraction, like 10% of the mass of the galaxy. And so this is the kind of the thought experiment. This is the theory that it sort of explains this. There's a bunch of independent lines of evidence for dark matter, but this is one of them. Think about the solar system. Think about how fast Mercury is going around the sun. Mercury is about 48 kilometers per second. Earth is going 30 kilometers per second. Neptune is going 5 kilometers per second. So Mercury is going around and around and around. Earth is going more slowly around. And then Neptune takes, 170 years to go around the sun. And so if a galaxy is the same thing, but just at a vaster scale, then you would expect the same thing, which is that when you look close to the center of the galaxy, you would see stars that are zipping around the galaxy. And then when you go further out, you would see that the stars are going a little bit more slowly. And then when you get all the way out to the edge of the galaxy, the stars are going to go extremely slow. But that is mostly not what happens. For the vast majority of the stars in a galaxy, they are all going the same speed. So they're all going the same orbital speed around the galaxy together. And so it's not like the solar system where you've got all of these stars and they're all going on different tracks. Imagine you have a bunch of racetracks and the cars are going different speeds around the racetrack. The close one's going really fast, farther out, they're going a lot more slowly. And not just because it's taking them a lot more time, but they're literally going more slowly. So you've got a race car close in and you've got a person walking on the outer edge of this. But with a galaxy, it's more like a plate is spinning or a record. The whole thing is just turning. And all the stars are moving at the same speed. And you just would not expect that. You would expect that they would be more like a solar system. And so the only way that you can get that motion is if the galaxy is actually embedded within something that is way bigger. And this whole thing is just kind of spinning, right? Slowly rotating. And that is, 10 times the mass of the part that we can see. Now you get this motion as expected. But it is not entirely the same speed. In fact, there is this point, this cliff inside a galaxy. And once you get closer in, then the stars do actually kind of behave like you would expect in a solar system. So normally it's this smooth slow down in the solar system, but in a galaxy, they start very, very quickly orbiting around the center of the galaxy. Then they slow down, and then you get everyone from that point outward, everything is orbiting at the same speed. And, when you think about the discovery of the supermassive black hole at the heart of the Milky Way, about 20 plus 30 years ago, astronomers were able to finally observe through the gas and dust and actually see what was going on at the center of the galaxy. And they saw these stars that were in orbit around nothing, right? Around this supermassive black hole, but you can't see anything there. And so, when you're really close to the center of the galaxy, then things actually do move very fast. And we see this in other galaxies as well. It's time to shout out our new patrons at the $5 level and above. Stories from Space, Thomas Romer, Darren McMullen, Jamie Verdon, Carla Baker, Fidel Lopez, Ben Diedrich, E. Eliashar, Scott Schuliter, and Chuck Haberlein. Join our community at patreon.com/universetoday. Peach Potter, what is the most I can't believe this is my job moment you've had covering space? Oh, wow. I mean, so many. I mean, just like I experienced this kind of background level of I can't believe this is my job. Like that's just my day-to-day experience is I look at science papers. I look at the ones that kind of strike my fancy. I then hand those off to writers, many of which who have advanced degrees, and then stories that I'm interested in reading pop out the other side of this process. And then I get to talk to people and I get to share a view with a telescope. So that is like just the background. And I really feel grateful that I'm able to have this job. And I think there's a lot of people who are like YouTubers and stuff, and they get burned out. And you see this happen. Like, think about all of the YouTubers that you used to watch. They were successful. They were making money. They were at the top of their game. And yet it was just like they couldn't handle it. They didn't like it. And I think part of it is that you've just gotta enjoy the work. And you can't let yourself get kind of captured by the forces that are always trying to push you in places that are going to make you feel burned out. There's always this tendency towards making things more hyperbolic. I've been watching all the coverage of the Steam machine, which is this. I know this is like a totally divergent rabbit hole, but I'll bring this all back around together in the end, I promise. So the Steam machine is this, new system from Valve. We were all excited about it. Suddenly you had a console that was going to play your Steam library on the television. Maybe it was going to cost about $700, $800. Incredible. Now this thing is actually more like $1,100, more like $1,400, $1,500 when it's fully kitted out. And it still will do this job, but it's a lot more expensive, and people are sort of coming up with cheaper variant alternatives than the more expensive version. But if you look on YouTube, it is like the sky is falling. Everything has gone to hell. That this is the apocalypse. That the worst possible outcome that could have ever happened to humanity is now unfolding, and it's Gabe's fault. And the fault is not on Gabe. The fault is not on Valve. The fault is on the AI industry that is gobbling up all the RAM and all the processors and all of the video cards and all of the hard drives and all of the SSDs, and leaving us in this place where we have to just beg for scraps to be able to put together a PC that will just play our video games. But the tendency is to be hyperbolic, because that is what drives the clicks. That's what makes your job make you money. And I've just resisted. Like, even when I started to do interviews, they didn't get any traffic. They didn't get any, I don't care. I enjoy them. And that is the part that like when I am interviewing an astronomer, I am just in bliss. I am having so much fun asking my questions to this person, satisfying my curiosity. Like, if I would get electric shocks as my compensation for doing interviews, I would still do them, because I have so much fun conducting those interviews. Fortunately, I don't. I just get mediocre traffic and a fraction of the views, but I really enjoy them. And then that's the baseline. And again, I feel really, really grateful. And that's why I think I've been able to do this job for 27 years, right? Is I just keep going after whatever I find to be the most fun. But then you have the moments where you do have to literally pinch yourself, because, I've interviewed multiple Nobel Prize winners. I've interviewed astronauts. I've talked to astronauts while they're in space. I've watched a rocket launch. I've been to the Jet Propulsion Lab, Kennedy Space Center. I've met astronomers around the world in person. And that is great. When you send out an email to somebody who you can't believe they would ever want to talk to you, and they're like, yeah, that sounds good. And you get them on the screen and you're talking to them. It's crazy. It's amazing. They wrote a book that you loved and you're talking to them. It's amazing. So there's like too many answers. I think the most surreal one that's ever happened to me, and I think you can still find this on YouTube, is when the Interstellar movie came out, they were doing a press junket. And so they had, I think, Anne Hathaway and Matthew McConaughey, and then they had an astronaut from NASA and I think it was an astronomer, and then they invited me online to be in the middle of their hangout. And so I was answering questions about space to Anne Hathaway and Matthew McConaughey about the Interstellar movie, which was pretty surreal. And that was definitely one of the, I can't believe this is my job moments. Not anybody paid me for that, but still, yeah. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. This week's bonus question: do I follow NordSpace and their new launch facilities in Newfoundland? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who had joined me for the live show that this was made up of. I'm going to show you what happens when you buy a new telescope. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bieluck, Dark Finger, David Gilton, and David Matz, Enthralled Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smith, Michael Purcell, Nessa Ocean Guide, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rankaidu, Richard Williams, Sean Sargent, Stephen Munley, Team 49, Telescopes Canada, Vlad Shiplin, Wolfgang Klutz, and Zelda one more time with enthusiasm, who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So as you know, I am building my new smart telescope, and I'm really happy with the software. Everything is ready to go. The telescope is working. I put the autofocuser on it, and now I just need to do the testing with guests. And so I've got a couple of really cool guests who I've reached out to who will be joining me soon. But when you build a telescope, you summon the weather. And so we had a really crazy thunderstorm, pouring rain, and I just thought you would want to stare at 2 minutes of telescope sadness. All right, we'll see you next time.